We're in Precalculus on this Thursday, January 31st. Today we're on lesson 6-8, lesson. Probabilities and permutation, or probabilities of permutations and combinations. So, 2 days ago when Daisy was here, we did 6-7. I need to practice my enunciation a little bit here. In 6-7, we talked about the mixture of permutations and combinations with the reindeer problems, with spelling the word, with flipping a coin. Now we're going to add all of that, but with probability. So we're going all the way back to 6-1. What was 6-1? The definition of probability. What is probability?
Ooh.
Wait.
This was like years ago.
Probability with...
It's a fraction, right?
Yes, it's a fraction.
It's a fraction. What is the top part of the fraction? The numerator.
The total outcomes.
Total. I cannot spell today either. Total.
Probabilities? Possibilities?
Possible outcomes. Yep.
Audio.
Divided by what?
So,
The number. I'm just gonna add
the probability?
So I'll give you a hint. This actually belongs in the denominator.
them.
So total possible outcomes, that comes, that's right there. Interesting that it grabs it in two different pieces.
Oh, you did it in two different.
I did? Okay.
Yeah.
Total possible outcomes is on the denominator. The numerator.
Is, the total amount of things. Like, say, there's 6 people.
Oh, sorry. Oh,
Like, the total amount.
The total, how's it different than total possible outcomes? I think you know it, but you can't enunciate it.
Okay, so, the top would be of, say, what you did. There was, 8 students. And then, for the total possible outcomes, there's 2 groups.
Okay. It's still not, go back to your 6-1 notes. 6-1 notes. What was probability? Let's use those notes.
6-1. That was like years ago.
It was literally this year, though.
Oh.
Oh, a number of ways it can happen.
Yeah. All right. Unfortunately, or maybe fortunately, if you want a lot of practice, for us, it means that both the numerator and the denominator are going to need a bit of math. That means you're probably doing a combination for the numerator and a combination for the denominator, or maybe a permutation. I don't know. Usually they're going to be combinations for the homework tonight. But just be thinking, you need to be doing 2 different combinations, one for the numerator, one for the denominator. So, example 1, reader.
There are 8 students in Algebra 2.5. In Algebra 2, 5 girls and 3 boys. If Mr. Sandale makes a group of 4 at a random, what is the probability that everyone in the group is a girl?
Perfect.
So
This is a real problem, by the way, because
Are you assuming their gender?
they have told me their gender. It's self-reported. They have
Oh.
self-reported that there are 5 girls and 3 boys. It was not me. I asked if anyone was a dragon. No one said that. They said, I'm definitely a boy.
Really appreciate that.
All right. So let's talk about just setting up our fraction. Without using any numbers, just using words, what is our fraction? What's the thing that we're looking for? What's our numerator?
8, 4.
I said don't use numbers. Don't use numbers. Don't use numbers. What are the things I'm looking for?
Wait, say that again.
We're using this definition of probability without using numbers, using only words. What is our numerator?
So bright.
What is our numerator?
Where'd you get 8? Oh.
Just
Alright.
because there's a total.
Our numerator is 4.
Don't use numbers.
Okay.
Possible outcomes.
So number of ways it can happen. So
What are the things we're looking
the
for?
group
Of boys?
of girls.
All right, so we're looking for groups of,
4. I mean girls. Girls.
write down, groups
Sorry.
of 4 girls.
Oh. Wait, now we can use numbers?
I guess if you want to say,
Wow.
Groups of girls. We're looking for groups of girls out of what?
Of students.
Groups of students, exactly. And I guess I was being too harsh by saying you couldn't use a number, but it's groups of 4 girls versus groups of 4 students.
It smells a little weird in here.
That would be the desk behind you. Yep, I know what happened, and it was gross.
What happened? You need to tell us now.
I'll tell you off camera. All right, so we have
Yeah.
groups of 4 girls and groups of 4
Ooh.
students. So both of these are combination problems.
Dude, that was me.
Rochelle, what did you do in here? All right, so
Wait,
groups of
can
4
you please-
girls. Groups of 4 girls. How do I do that? How do I make groups of 4 girls? Tell me. It's a combination problem. What choose what? For groups of 4 girls, it's what choose what? Well, how many students do I have in total, right?
8.
There's going to be 8 choose.
Oh, 8. 8
Oh, we're doing
C-R.
this again?
8
4.
choose 4, exactly. Divided by,
Wouldn't the group of students be a group of 8 students?
oh, it would be. So 8 students, choose 4 of them. How many girls do we have to choose from?
5.
5 girls to choose from, and we have to choose 4 of those girls. All right, now we need to do, what is 5 choose 4? And I do not want you using the NCR function on your calculator. I want you to be able to do this by hand. We just did this for a warm-up. 5 choose 4.
We didn't. Oh.
We literally just did this for the
Yeah, we
warm-up.
did, we did.
I have a
That's
group
not
of
right.
5, and I
Wait,
want to choose 4. How do I do this?
listen, listen,
So
listen.
it's like factorial.
So
no, I'm
it's
joking, I don't know.
it's 5 factorial
Ha!
divided by 4 factorial.
Careful. It's, well, I guess if you're using the formula, it is 5 factorial divided by
5 minus 4.
5 minus 4 factorial, and that's,
Oh, 4 times by 5 minus 4 factorial.
But isn't that... Oh, okay, yeah.
there it is. So there's our formula for doing a combination.
I really don't like the smell of Mr. Snow.
I'm sorry. Do you want to open up the windows again?
Please. I'm literally covering...
All right, windows are open. We have diffused the smell, hopefully.
Thank you.
All right, how do I do 8 choose 4? What's the formula?
Would that be 8 factorial over 4 factorial times 8 minus 4 factorial?
It is 4 factorial
There's a lot of factorials
times
in here.
8 minus
And 8 factorial.
4
I
factorial.
actually like it.
I don't like it. So much more complicated.
These scared the heck out of freshman college person, Mr. Sindel,
Why?
because I didn't know how to do division with factorials. Not until my second year of college. Really sad story,
We're
but
smarter than him. Nah.
oh yeah, you are. All right, so how do I do this? Well, if I'm dividing, it's keep it, change it, flip it, right? This fraction divided by this fraction is keep it, change it, flip it. So here we're going to rewrite this. My blue function is keep it, 5 factorial divided by 4
Can we
factorial
just leave it as
times.
5 factorial over 4 factorial? Because we basically know it's just going to be 5 over 4 factorial.
Yeah, 5 over 4 factorial. I like it. And that's going to be now, change it and then flip it. Now it's going to be 4 factorial times 4 factorial. All of this divided by, I guess I should be doing all this in yellow. I don't know what I'm doing here. I'm trying to color code it. 4 factorial times 4 factorial. All of this divided by 8 factorial. So far, so good? Okay, let's start crossing things out. I love crossing things out. How do I cross things out?
You can cross out 4 and 4.
Yep, the 4 factorial and 4 factorial. And that's basically all I can do.
Oh, there you go. There you go.
So the easiest way to simplify this guy is to write out what 5 factorial is. So we have 5
So it's not 20.
times 4 times 3. I'm just going to say 5 factorial.
Wait, so it's not 20 over 20 factorial over 8 factorial?
No, you can't. That's not how factorials work, actually.
Oh my god.
It's not 20 factorial on the top.
That's so
It's 5 factorial times 4 factorial. And then let's move 8 factorial out. So it's 8 factorial is really 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? Which is the same thing as saying 5 factorial right here, yeah?
Wait, so that means it's going to be like 1 over whatever 8 times 7, 8 times 6 equals? Right?
I think you're ahead of me. I don't know if that's you said it's 1 over because you still have this 4 factorial to deal with.
Yeah, the 4 factorial was going to cancel out, so it will.
The 4 factorial doesn't. It's the 5 factorial that we're going to cancel out right now.
So
Wait, why would it be 5 factorial when you're doing the 8 factorial? Like when you're like.
So if you want me to write this all out, I can. This is the shortcut here. I'm going to write it all out.
Okay, no, I understand, but like, why would you?
Why did I what?
Never mind.
No, I'm not trying to be sassy. I really want to help you.
No, I know, Mr. Steele. Okay. No, I understand now. Yeah, because you're crossing them out.
Yeah. There's no more 4 factorial because the 4 that was going to be here got canceled out before we could get to it with the 5
Wait,
factorial.
but wouldn't the 4 be canceled out first and then the 5?
You can either choose one or the other.
But you can't do both.
You can't do both.
Dang it.
Why?
Yeah. I chose the biggest one to get rid of because it makes it easier. You could have chosen to get rid of the 4 factorial. So let's write out what 4 factorial was. Let's come back here. I'm going to erase the 4 factorial. The 4 factorial is really what? I don't know why this program does that. It's so annoying. Okay, it's really 4 times 3 times 2 times 1, right?
So it's, 120.
So let's go ahead and simplify this fraction. 4 times 2, right here, 4 times 2 is 4 times 2,
Oh, 8.
8, and there's an 8 on the bottom. So the 4, 2 cancels out. And what about 3 and 6?
3 and 6?
3 and 6 reduces to,
Yeah, oh,
that goes away, and that turns into a 2. So I really have
1 over 17.
1 over, yeah, there it is, 1 over 14. There it is. So, and this is a real problem.
Wait, why is there a 2?
So when we cross out the 3 and the 6, 3 turn into 1, 6 turn into a 2.
Sorry. Yeah.
I tried color coding it. It's still a little bit hard. Yeah, this is a real problem, though. So if you want to talk to the Algebra 2 class and say, if Mr. Sindel, because I always make groups of 4. I do it almost every 2 weeks. I make a group of 4. You can say, did you know that there's a 1 in 14 chance that everyone in here is going to be a girl for this group? You know that now. Pretty cool, huh?
Wait, so there are actually 8 people in Algebra 2?
Yeah, there are 8 people in Algebra 2. 5 of them have self-reported that they are girls. 3 of them have self-reported that they are boys.
Oh, you're talking about your actual class.
This is my actual class.
Who's in Algebra 2?
So Algebra 2 goes, I have both the Stephanies. I have Geo, James, and
Chris, right?
Geo, James, Chris, and then I have the 2 Stephanies. Who are the other girls? Andrea, Eva, Fiona.
5. That's 5.
It's 5? Okay, I was like, someone's going to get mad at me. All right, there's the answer. Let's do number 2. Flipping a coin. If you flip a coin 7 times, what is the probability that you will get exactly 3 tails? Again, without using too many numbers, I really want kind of the same setup as we did before. What is the numerator? What is the denominator?
7 goes up. Wait, no.
He said without using numbers, Rochelle.
Well, okay, you can use a number. I don't want to be strict. I don't want a number like 7 over 3 or something like that. I want a full sentence using a number for the numerator. Very similar to what we did for example 1.
Group.
Well, here's one of them. 3 tails is either the numerator or the denominator.
Oh. Would be the denominator.
That's the thing we want, right? The thing that we want is the top. Maybe we can add that to our notes up here. This is the want.
It's kind of confusing because numerator, denominator, the definition for the probability, they're basically the same definition, just written in different words.
Okay, maybe this is a better definition. The things we want versus all the ways it can happen. I'll work on those definitions. The things we want versus all the things. So this is the thing that we want, right? 3 tails. So 3 tails. That's our numerator. Our denominator is
7 times.
7 times, yeah. So how many possibilities, which one do you want to do first? I guess we'll do the numerator first. 3 tails. How many ways can you get 3 tails? Does it matter if the tails is first or second? Or does it matter that you get 3 of them?
Matters that you get 3.
So order Does or does not matter?
It does. It doesn't?
Stop looking at me like that.
Just give me the blank look until you give me the right answer.
We did
You gave me the
answer.
You don't know why you give it, though. You don't know which one it is. So,
Well then.
okay, think about this. I'm flipping it 7 times. Boom, 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 flipping it 7 times. Let's say the first 3 I get tails, and the next 4...
If you get exactly 3.
Yeah, so the first 3 I get tails, and the next 4 I get heads. Is that the same thing as getting the last 3 tails and the first 4 heads?
No. But yeah.
I still get exactly 3 tails, right?
Yeah.
But I did it in a different order. Which means order
Doesn't.
does not matter. Does not matter.
He was just really explaining.
I know, say doesn't. You didn't let me finish.
I do.
It does not matter, which means it's a combination or a permutation.
Go.
Permutation. Wait,
No,
no, it
it's-
doesn't matter. Combination.
Combination.
No. Wait, yeah.
When order does not matter, it's a combination. So, what is my NCR? N is, yep, so it's going to be 7, choose,
A 3.
3, versus what? This one is going to be tricky. This one's going to be very tricky. What's the denominator? It's not even a choose or a permutation.
Is it going to be 7?
This goes all the way back to notes. I want to guess 6-2, maybe 6-1. Flipping a coin.
Oh, is it with P? With probability of A and B?
Wait, what?
No.
6-3?
Or I think I would guess 6-2.
Let's see.
When you're flipping a coins,
Oh. 7 to the power of 3.
you're so close. You have the formula right. You chose the wrong numbers.
3.
How many different ways can a coin land? How many different ways can a coin land?
2.
That's our base. All right.
Oh.
2 to the power up, and then how many times am I flipping it?
Oh, 7.
There it is. So technically it's a, I guess you can think of this as a combination as well. But it's a combination. I guess this was in our permutation notes. I'm forgetting where this was in our notes, but there it is. There's our formula.
Ew.
Help me do 7 choose 3.
I feel
It's a
uncomfortable.
song. It's a song. Have you heard She's a Manager?
Okay.
7 choose 3. How do I do this?
It's 7 over
7
Factorial.
factorial divided by
7 factorial. Wait. No, 3 factorial times it by 7 minus 3 factorial.
Okay, that's the top, and then the bottom we can't really simplify. Bottom stays.
Why can't I simplify?
I mean, if you want to write it out 2 7 times, I guess you could do that.
Oh, not like that, but like I meant like answer.
Yeah, I mean, we can now simplify this because technically this is 2 to the power of 7 over 1. So I have a fraction divided by a fraction, so keep it, change it, flip it, just like we did before, right? So keep it. 7 factorial divided by 3 factorial times 7 minus 3 factorial.
4.
Oh, I guess we should just simplify it while we're here. 4 factorial. And that's going to be now times, so we'll say black here, times, and then our green function, 2 over 7, or 2 to the power of 7. Oh wait, flip it. I didn't even flip it. There we go. 1 over 2 to the power of 7. All right. So we can simplify this factorial a little bit, but there's not that much we can do here. Yeah, there's not too much we can do. And by the way, for Khan Academy, the homework, they don't want a decimal. Obviously, I could do 1 divided by 14, 1 divided by 14, and it's a decimal that goes on and on forever. But they don't want this decimal. Or, sorry. They don't want this decimal. What they want is the fraction, 1 over 14. So they do expect you to be able to reduce this on your own. So this one is also going to be entered as a fraction. We can't use our calculator. How are we going to do this? 7 factorial and 4 factorial. Those can be reduced to what? 7. Write out 7 factorial until you hit one of these numbers. 7 times
4.
7 factorial
Oh,
is
6. I'm sorry, 5, 4.
times 4 factorial, right? 4 factorial says it goes on and on forever. This is all going to be divided by this 3. We'll write out 3 factorial since it doesn't get canceled out. The 4 factorial does get canceled out. We'll write that here. 3 factorial now is 3 times 2 times 1, which is just 3 times 2. And we still have this 2 to the power of 7, this pesky 2 to the power of 7. All right, those 4 factorials, they do cancel each other out. Can we simplify? 3 times 2 is,
6.
and that simplifies with the,
14 times about 5.
all right, what?
Because once you take off 3 and 2, that will leave 6 and 2. Oh, wait, never mind. So it's just 35.
Yeah, so this is going to be 35 over 2 to the power of 7. So rewriting this now, this is going to give us 35, come on computer, 35 divided by 2 to the power of 7. What is 2 to the power of 7? Can you do this in, by, not necessarily in your heads, but on paper?
No.
It's 2 7 times. So I'm going to write out 1, 2, 3, 4, 5, 6, 7. 2 times 2. 2 times 2. 2 times 2. 4 times 4. 16. 4. I haven't used this 2 and 4, so 2 times 4 is
8.
And maybe that's going to be the harder way of doing it. Maybe we should do it like this. I don't know. I've multiplied by 2 so many times in my life, and yet I'm struggling now.
Ah,
I don't know. This program is being...
it's 122.
It's what?
122.
It is not 122.
Really?
No. 16 times 2.
Ow!
16.
That would be 32.
Mother trucker.
32 times 2.
64.
64 times 2.
128.
There it is.
Oh, I messed up. What's 8 times 6?
8 times 6 is 128.
No, 8 times 6.
Oh, why did you do times 6? Oh, 8 times 6 is... Okay, I see what you're doing. You're doing the last decimal place, right?
So I put no. Okay, so it's 48, and then that's why I messed up. And I put 42.
I see. Okay. Can we reduce this fraction? Are the top and bottom both divisible by 2?
No.
No, because 35 is not divisible by 2. Are the top and bottom divisible by 3?
Yes. No.
How can you tell?
Because 35 is
Yep. What's the shortcut of doing divisibility by 3? Can I check if 128 is divisible by 3? Add all the digits together. 1 plus 2 plus 8. What is 2 plus 8?
10,
Plus 1?
11.
Is that number, adding all the digits, divisible by 3? Is 11 divisible by 3?
No.
Then 128 is also not divisible by 3. That's your shortcut. Are they both divisible by 4 or 5 or 6 or 7? Ooh, maybe 7, right? 7 is a little bit harder to check for the divisibility. There's a cool chart that I can show you, but we can check just on our calculators. 128 divided by 7 is indeed not divisible. I think that is as reduced as we can get it. And if I'm wrong...
Reducing Khan Academy, they won't get it wrong, right? They won't get it wrong.
I haven't actually tested that. I don't know. I don't know if you don't reduce, if you get it wrong. I
think
assume that
they'll
they'll...
just ask you, though.
Usually they're pretty good about saying, hey, you didn't reduce your answer, and they'll make you have to reduce it. But there it is. So there's 2 types of problems that I saw, at least on Khan Academy. Flipping a coin and choosing groups.
So much work.
And you've seen all the tricks now. So go ahead and write your summaries. Your summaries are going to have some trick about, some trick with, why am I blanking on this? With factorials, or maybe how to set up your fraction, or maybe your better definition of what probability is. Something like that in your summary. All right, that concludes the notes.